Welcome to Coding with Arduino for Young Innovators, a practical program designed to introduce young minds to the exciting world of STEM education, coding, robotics, electronics, and innovation. In today's video, we will solve the assignment from our previous class and introduce a new component included in the Ettronics Hightech Arduino Kit, which we will use to build exciting projects as we progress through the program. In the previous video, we built our first project with the Ettronics Hightech Arduino Kit and discussed some of the basic concepts you need to understand about electronic circuits. If you would like to follow along with the project, you can purchase the kit using the link in the description of this video. Send us an email or chat with us directly. So, here is the assignment. Add a second LED to the circuit and use the same switch to control both LEDs. Your circuit should be designed so that when one LED is on, the other LED is off. And when the first LED is off, the other LED is on. This was the circuit we had in the previous class. It is a simple LED circuit that behaves in such a way that when we turn on this power supply, this breadboard power supply, which has batteries connected to it, when we turn it on and we slide this switch, this LED will come on. Sliding the switch here means the same thing as turning on the switch. So if I turn on this power supply and slide this switch to this end, this LED comes on. But when I slide it to this side, the LED goes off. Now, the assignment says that we should add another LED to the circuit such that we can use this same switch to control the two LEDs. And the circuit should behave in such a way that when one LED is turned on, then the other LED should stay off. And when that LED is turned off, the other LED should come on. So what it means is that we are going to use this same switch to control two LEDs. That means we're going to add one LED to the circuit with its accompanying current limiting resistor. And then we should connect the components in such a way that we can use this switch, this single switch, to control the two LEDs to behave in the manner that I described earlier. What I will do now is to bring an extra LED and a current limiting resistor and connect to the circuit. So here I have an extra LED, an extra light emitting diode, and another current limiting resistor. Remember that the current limiting resistor we are using is the 220 ohms current limiting resistor. You have all these components in your Ettronics Hightech Arduino Kit. So to connect the circuit to realize the assignment results, I will disconnect the components I have already on the breadboard and reconnect the circuit. So the first thing I will connect in the circuit is my switch. If you look at this switch, you can see that it has three legs. So I will connect it here in the circuit. And then I will connect a jumper wire to the positive terminal of our power supply. The positive terminal of our power supply is the hose on this red line. So I will connect it here. And then I will connect it to the middle leg of this switch. So I will find out where the middle leg of this switch is and connect it there. So here is where the middle leg of the switch is connected on the breadboard. I will connect this jumper wire there. Okay, the next thing I will do is to connect the first LED. To connect the first LED, I will do so through a current limiting resistor. I will pick one current limiting resistor and connect it to one of the two remaining legs of the switch. So we have the middle leg of the switch already connected to this jumper wire. I will connect this resistor to the right pin or the right leg of the switch, as you can see here. And then I will connect the other leg of the resistor to any other points on the breadboard. I have done that. Then the next thing I will do is to connect one LED, the first LED. I will connect the positive leg of the first LED to the other leg of the resistor. To identify the positive leg of an LED, you look at the leg that is longer amongst the two legs. So this leg of the LED, or this pin of the LED, is longer than the other. So that is the positive leg of the LED. I will connect it to this leg of the resistor. And the other leg of the LED, which is the negative leg, I will connect to ground. Remember that ground is the negative terminal of our power supply, which is our battery. Here we are using the breadboard power supply, which has batteries connected to it. And this breadboard power supply helps us reduce the voltage of the batteries to the level that our circuit can comfortably work with. Now I will connect another jumper wire to the negative leg of the LED. I will connect one leg here, and then I will connect the other leg here. Now you can see that the jumper wire is connected, one leg or one pin to the negative leg of the LED, and the other leg to ground, which is the negative leg of our battery or power supply. I can use any hole on this line, so I chose this hole. The next thing to connect is the other LED. To do that, I will connect it through a current limiting resistor, which is this second resistor I have here. Remember that this resistor is 220 ohms. You have it in your Ettronics Hightech Arduino Kit. I will connect one leg of this resistor to the other leg, or the remaining leg of the switch, which is the leg on the left side. I will connect one leg of the resistor there, and the other leg of the resistor I will connect anywhere on this side of the breadboard. And then I will connect the LED, that is the light emitting diode, the second LED. I will connect its positive leg to this other leg of the resistor that is now connected to somewhere on the breadboard. To identify the positive leg of this LED, I will do what we did earlier. That is, look at the legs of the LED and identify the longer leg. The longer leg of the LED is the positive leg. So this leg is the longer leg. Hence, it is the positive leg of the LED. I will connect it to this other leg of the resistor, and we have the negative leg of the LED hanging. And what I will do is to use another jumper wire and connect to that negative leg of the LED and connect the remaining leg of that jumper wire to the negative terminal of the battery or ground. So I will pick this jumper wire and connect one pin of the jumper wire to the negative leg of the LED here, and then I will connect the other leg of the jumper wire to ground, which is here. Now our circuit is complete. To test our circuit, I will turn on this switch. When I turn on this switch, if everything is fine with our circuit, automatically one LED will be on while one will be off. And when I slide the switch to another side, the LED that was on previously will turn off, while the LED that was off previously will turn on. So let me turn on the power supply. Perfect. Now you can see that this LED is on while this LED is off. Now, this shows that our circuit is working, but we are not yet sure if it is working entirely as we expect it to work. To test if the circuit is working exactly and entirely as we expect it to work, I will slide this switch to the left because it's already on the right. When I slide it to the left, I expect this LED that is already on to go off and this one to turn on. If it works as I just described, that means that our circuit is working exactly as we expect it. However, if it did not work as I described, that means that our circuit is not working as expected. At that moment, we need to troubleshoot the circuit to find out what is wrong and then fix it. So let me slide the switch to the left and see what happens. And you can see our circuit did not come on. That shows that something is wrong with our circuit. So I will slide the switch back to this side, and then you can see that this is on. I will slide it to this side. This is not coming on. Now, what I will do now is I will check my connections to know if there's anything that is not well connected. I will start by looking at the resistor connected to this switch. And looking at my connection, I think everything is fine with my connection. Everything is fine with my connection. Let me look at it again. I think everything is fine with my connection here. Now let me look at the other connections. Okay, I have this one. I've pressed the resistor in very well, and I have my LED. Let me check. My LED is connected as it's supposed to be. Positive here, negative here. Well done. Then my jumper wire. My jumper wire is connected as it's supposed to be, as it should be. It is connected as it should be. I will test again, and you can see that the LED did not come on because this LED is working and this is not working. So I will zero down the problem to the LED. What I will do now is to change this LED to another LED. Perhaps this LED is faulty. So let me bring another LED and replace this one. Okay, here I have another LED. I will remove this one, keep it here, and then replace with this one. I'll identify the legs, and this is the positive, this is the negative. I will connect it. And now I can test to know if the circuit is working as expected, to know whether we have fixed the problem. So I will slide this switch to this side, and you can see that the LED is on. So the problem with our circuit was the LED. I will slide it again to this side. This is on, this is off. This side, this is on, this is off. On, off, on, off, on, off, on, off. So this is exactly how we expect our circuit to work. It is working exactly as expected. So here, we've been able to use one switch to control two LEDs, whereby when one LED is turned on, the other will be turned off. And when this one is turned on, this one will be turned off. What makes this possible, like I said, is this switch. This switch is what we call the single pole double throw switch. You'll get to know more about it as we progress in using the Ettronics Hightech Arduino Kit to create more exciting projects. So this is the solution to the assignment we had in the previous class. Here is the circuit diagram for the design. You can see the switch as it can be used to control two LEDs. So when the switch closes to this side, current will flow in this path and turn on this LED, while the circuit on this part will be open. Hence, no current will flow around it. However, when the switch is closed on this side, it means that current will flow around this part of the circuit, while this part of the circuit will be open. Hence, this LED will be on, while this one will be off. That is the solution to our assignment. Another type of switch included in the Ettronics Hightech Arduino Kit is the push button, also known as a momentary switch. Unlike the switch we used earlier, a push button closes the circuit only while you are pressing it. The moment you release the button, the circuit opens again. This is why it is called a momentary switch. Push buttons come in different shapes and sizes. In the Ettronics Hightech Arduino Kit, we have about two different types, this one and this one. We also have another type, which is this one, and there are many other types available. This was the type of push button we used in some of the earlier videos in this series before we started using the Ettronics Hightech Arduino Kit. If you want to build those projects, you can use either this push button or this one. The main difference is that these ones have 4 legs, while this one has 2 legs. However, there is something important to understand about the 4-legged push button. The 2 legs on one side are internally connected, and the 2 legs on the opposite side are also internally connected. In other words, this leg and this leg are connected together, while this leg and this leg are also connected together. Same thing is what we have in this one. This leg and this leg are connected together, while this leg and this leg are also connected together. Let's use this push button to make the same LED circuit we made earlier. So to do that, I will disconnect this component from the circuit. And then I will connect this push button to the circuit. You can see that we have the demarcation in between these 4 legs. So this leg and this leg are connected, while this one and this one are connected. So what I will do is that I will connect the push button like this on the breadboard. So by connecting this push button switch like this on the breadboard, I can use this and this as the 2 legs I need for my circuit, or I can use this and this as the 2 legs I need for my circuit. So let me connect the circuit and we will test how this switch works. I will connect the positive terminal of the power supply to one leg of the switch. Let me connect it to this leg of the switch. And then I'll connect the current limiting resistor to the other leg of the switch, which is this leg. And then I'll connect the other leg of the resistor to any hole on the breadboard that is not where we connected the first leg. Now I will connect an LED to the resistor. I will connect the positive leg of the LED to the other leg of the resistor, which is this leg. And I will connect the negative leg of the LED, which is this leg, to ground or negative leg of the power supply or battery. So I will connect this here. And then I will connect this leg of the jumper wire or pin of the jumper wire to ground or negative leg of the power supply. Now our circuit is ready. We just replicated the first project we did in the last video, but this time around not with this switch. This is a latched switch, a single pole double throw latch switch. Here we are using the push button switch or momentary switch. You see, when you press it, it stays there, and when you remove your hand, it goes off. So what I will do now is to test the circuit. I expect the LED to come on when I turn on the switch. As long as my hand is pressing the switch, I expect this LED to remain on. But once I remove my hand from the switch, I expect it to go off. So what I will do now is to turn on the power supply and press the switch. So let me do that. And you can see that the LED is on. When I remove my hand, it goes off. On, off, on, off, on, off. We can also use the other switch to realize the circuit. You can see that this switch has also a demarcation in between, separating these 2 legs from these 2 legs. That means these 2 legs are connected, while these 2 legs are connected internally. So I will connect the switch like this. So I have done that. Then I will turn on the circuit and I will press the switch. I expect when I press this switch, this LED should come on. And when I remove my hand from the switch, it should go off. So let's test it. It is on, off, on, off, on, off. That is how a push button behaves or a momentary switch behaves in a circuit. All right, now that you understand how to use the push button included in the Ettronics Hightech Arduino Kit, you can proceed to build the exciting projects we've created so far in this series. We have built projects such as the LED chaser circuit and distance measurement with Arduino and ultrasonic sensor, with many more exciting projects to come. I'm Instructor Izu. See you in the next video as we continue building exciting projects with the Ettronics Hightech Arduino Kit. Bye.